Thanks for joining first. My name is Daniel Pohl. I'm a cloud native architect working for Portworx. I want to explain or tell you what we can do with Rancher and Portworx in combination. So, thanks for joining. So my agenda, why Portworx and what is it? Just a quick introduction. Don't know if you already had contact with Portworx and know what it is. Nope, no one. Great. Little bit. So hopefully we can clarify today. So why Portworx and what is it? And then also how Portworx can help with data management on Rancher. And I will especially talk about 3 topics. So our autopilot, app I/O control, and the trash can. Just as a few examples what we can do on the platform. So, but let's first start. So mainly we focus on storage for Kubernetes. We come into the game whenever you start deploying Kubernetes clusters and Rancher clusters with persistent storage. Are you already running persistent storage on Kubernetes, or is it still stateless? Stateful. Okay, so what we experience when customers go into state in Kubernetes, let's go 10 miles above. When customers start with Kubernetes, they often start at first with stateless workloads, because this was kind of the first Kubernetes idea, having stateless workloads running on those clusters being orchestrated. And in this first phase of implementing Kubernetes into their environments, customers usually start with stateless because they have many other things to solve in this period. So they start with stateless. As soon as they established Kubernetes in their environments, integrated it into their development pipelines and stuff like this, they start with the second phase, where developers usually start to ask for stateful workloads in Kubernetes clusters. So they ask for, I want to deploy a MySQL database, or I want to deploy MongoDB or Elastic or Kafka in the clusters. And that's the point where people usually start playing around with state. And each and every Kubernetes distribution, each and every platform has a solution for providing state for Kubernetes clusters. So they usually start with CSI drivers, or they start with Longhorn on Rancher. They start with ODF on OpenShift. They start with the CSI drivers in the public cloud and the hyperscalers. Or they even ask their storage providers to provide a CSI driver for their specific storage array. So they find a solution to implement storage on their Kubernetes clusters in this second phase. Often those customers don't have an SLA for storage in this second phase, so they tell their developers, okay, you can deploy a MySQL database, but there's no SLA on it. Things might happen, we don't care. In the second phase, developers start deploying stateful workloads on Kubernetes, gather some experiences on this, and then there might be a third phase starting. And this third phase is about now these applications go into production. And now people start asking questions about these stateful solutions. What's about high availability in this cluster? Do we have a solution for this? What happens when things break? What's our solution for maybe a hybrid solution? So we don't have, we're just not having this on-premise cluster. We might have a second, a third, a fourth cluster, which might run on another platform, which might be in the public cloud, which might be another Kubernetes distribution. Do we have a solution to migrate data from this first cluster to another one? And do we have a solution to do this in a Kubernetes native way, so without building scripts and doing some weird stuff in the infrastructure? What's our solution for disaster recovery in general? What happens when this full cluster fails? Can we fail over to another Kubernetes cluster and just start our production there? Yeah, on the Kubernetes layer, that's quite easy. You just deploy your workloads on another cluster and they start running. But what happens with the state? What's our solution for encrypting data? Because we need to go to the public cloud and we need to ensure that data is encrypted in all of our clusters. And last but not least, what's about backup and recovery? How do we back up and recover those workloads on Kubernetes? And this is all questions which will rise at this point where these applications get critical, important, business relevant. And another piece also is low performance at scale. How do I manage performance in those clusters? How do I ensure that performance is available for the applications? And how do I monitor if it's not? And what might be the root cause? So all these challenges we see usually start in this third phase of deployment. It's about performance, it's about outage, it's about also operational complexity. Now I have multiple Kubernetes clusters with multiple different storage solutions underneath. Think of you're running on-premise Rancher with Longhorn, you're running in the public cloud Amazon with a CSI driver of Amazon, and you might also run another Kubernetes distribution with another storage solution. And this leads to operational complexity. You need to know how storage works in each of those clusters, and you need to know how to monitor, how to manage, how to HA, if possible. And this is something we often see in larger environments, in growing environments. And that's the point where we come into the game. So what we see on the challenges side is inefficient resource consumption and low application capacity at scale. What does it mean? Inefficient resource consumption. Think of you running workloads in Amazon EKS, for example, consuming EBS volumes via a CSI driver. These are not thin provisioned. So you pay for a lot of storage you might not use. That's a specific problem on hyperscalers. You might not have this problem in your on-premise Rancher environment, but it's difficult to manage all your storage with all these differences underneath. I already mentioned the business continuity challenges. What happens if you have downtime, if you're losing clusters, if you need a disaster recovery solution? And also, what about the operational challenges? So all these multi and hybrid cloud things, which just increase the load for your platform teams to manage all this stuff. And let's say a desired solution for this would address all these challenges. So in a desired solution, you would have one solution to manage your storage in all these different clusters. You would also have business continuity solutions between these clusters, which could also offer you, for example, a zero RPO disaster recovery solution. So you won't lose any data if a full cluster is failing. And you would also have a centralized management, so the capability of managing storage in first a Kubernetes native way. Think of a GitOps-driven approach. And also having the same capabilities in each cluster to manage storage independent from the underlying architecture and the underlying platform. And this is what Portworx brings into this environment. So Portworx is a data platform for Kubernetes, which technically runs as a Kubernetes native application within your Kubernetes cluster. So don't think of it as a centralized appliance or something like this. It's a software which runs inside the Kubernetes clusters and provides a storage layer for these clusters. And with Portworx, you can automate all storage-relevant tasks within those clusters. So for example, if you implement a solution to do a application-consistent snapshot, for example, for a MySQL database on a cluster running Portworx, you can use this solution on each of your clusters running Portworx, no matter what the underlying storage solution might offer or might not offer. So with Portworx, storage looks the same in each of your Kubernetes clusters, independent from the underlying infrastructure, Kubernetes distribution, cloud, or whatever. If you're running a bare metal cluster with just disks in it, Portworx is managing storage the same way as it would do it like in an Amazon EKS cluster. And this has a huge benefit when it comes to management. And it also has a huge benefit of reducing risk in your organization, because the knowledge how to manage storage is just needed once. You need to know how Portworx is working and not how my on-premise storage solution works, how CSI drivers work, and maybe also another Kubernetes distribution storage solution might work. And with this standardization of storage within the clusters, you can automate this stuff. So it helps you to automate deployment, management, lifecycling of storage within your clusters. I will come to this also in the three topics I'm talking about, because these are all about automating and standardizing stuff. And with Portworx, you can protect your data. So as I already mentioned, we have a solution for disaster recovery, and I will also show this in a high-level slide after this. We can implement business continuity for your clusters. We can do container granular backups and restore. And again, as I said, we can unify management and operations for these clusters. So you have a, let's say, cloud-like operating model for your storage in Kubernetes, and we can manage containers and VMs also on Kubernetes the same way. That's also a very interesting thing. We have many customers now asking about, okay, can I also bring VMs into Kubernetes using the KubeVirt project? And yes, you can. So we just provide the storage layer for it. Additionally, we also have a solution which solves a problem we actually bring into customers' environments. Now think of, you could provide your developers a stable platform to deploy databases in the Kubernetes clusters, because you now have a solution for have a high performance, stable storage solutions in Kubernetes. Developers tend to consume this. So we have customers with multiple Kubernetes clusters ending up in a situation where they had multiple deployments of multiple different database products in their different clusters. So think of your developers start with MySQL. If you have 10 Kubernetes clusters, you would install 10 times the MySQL operator into your clusters, and it would manage these MySQL databases. And now the next developer comes and says, okay, now I need MongoDB. Okay, you install MongoDB operator in all of your clusters. Now you have 2.1 and 20 different instances of databases in your 10 clusters. And now Cassandra comes into the game, Kafka comes into the game, and all these other products. You might end up in having many operators installed, no idea what happens in the clusters, and no centralized point where developers can just request a database, and no centralized point where your platform teams can have a look onto all these database deployments and see what might be a performance issue, what might happen about backup and recovery. So with a joint customer, we added a new product 1.5 years ago, which is the Portworx Data Services. And you can think of it as a centralized control plane for database deployments on Kubernetes. Because with Portworx Storage, we provide the layer for high available storage. And now with the database or the data services, your developers have a single point where they can go to, where can they point their developer pipelines to. We have an API and a UI, so developers can say, I want a Postgres database version 13 in this cluster, and it would deploy this solution into the desired cluster. And you would have a single point of view to all of these databases instances. You can check if they are running properly, if they're configured following the right templates, if they're backed up, if you can restore them, all these pieces. So that's an additional layer we add to our solution. But all of these solutions we have, so the storage, the backup and restore, and also the database control plane, have one thing in common. They are independent from the underlying infrastructure. We don't care what your storage provider is and where your storage comes from. We also don't care about your Kubernetes management. We support all major Kubernetes distributions, Rancher, but also OpenShift, Tanzu, upstream Kubernetes, EKS, GKE, AKS, you name it. So we are the only solution providing a storage platform for all of these solutions, independent from the Kubernetes layer and also independent from the infrastructure layer. We have some integrations into the platforms. So for example, if you're running your Kubernetes clusters in one of the 3 hyperscalers or on vSphere, we have an integration to them, which helps managing stuff, and I will point to this in one of the bullet points later. But in general, we work everywhere. So we consume whatever the platform gives to us on storage. We abstract this and provide a unified layer of storage to the Kubernetes workloads. So let's have a high-level view onto the business continuity stuff I was talking about. Something happened with the logos. So I have a source cluster. This is running my workloads. This is managed by Rancher. Portworx is providing the storage layer to the workloads. So technically, we act as a provisioner for storage classes. And now you can set up a second cluster, also with Portworx. This second cluster could be in another infrastructure. This could run on another cloud. It could even run on another Kubernetes distribution. And now you can implement a so-called cluster pair between those 2 clusters. And that's just a YAML spec, because we are Kubernetes native. And you can create this YAML spec, and this YAML spec describes basically how this cluster can access this one. So it contains a secret, it contains the endpoints, and some configuration data. And we call this a cluster pair. It's a Kubernetes CR. You can create multiple of those cluster pairs if you have multiple clusters. And it first just implements the connection from cluster 1 to cluster 2. That's the first step. To implement asynchronous disaster recovery, you need 2 additional steps. The second is you create a schedule. That's just a small little piece of YAML describing how often things should happen. So you could name it 5 minutes, and it has an option which says schedule equals 5 minutes. And the third thing is the actual migration. So now on a namespace level, you can create migrations within this cluster. And for example, the owners of the Postgres namespace could create those migrations. It's again a YAML spec, which describes what to do. So it says, I want the Postgres namespace being migrated following the 5-minute schedule using the cluster pair cluster 1 to cluster 2. And as soon as you apply this, Portworx would start snapshotting all the volumes being consumed from the namespace. So here in this example, we did this for Postgres, Mongo, and MySQL. We would snapshot all the volumes being consumed in this namespace. We would also take all the Kubernetes objects and migrate them using an object store in between to the second cluster. And the second cluster would create all these elements. So Portworx would create all the volumes here out of these snapshots we did. And we would also create all the Kubernetes objects. So if you would now take a look into the second cluster, do a kubectl get all PVC, you would see all the PVCs, you would see all the Kubernetes objects. And the only difference would be the replicas are scaled to 0, because that's disaster recovery. And this would now happen again and again following the schedule you defined, so the 5-minute schedule. So every 5 minutes, the production cluster would snapshot the volumes, would take the differences from the last snapshot, would transfer them to the other cluster, and would update this. So this is an ongoing process in the async DR. And in case of a disaster, you would have a single command on the second cluster, just telling it, okay, the disaster happened, scale it up. And technically, in the background, Portworx would just change the replica to the original number of the source cluster. Kubernetes would schedule the pods, everything would start. That's just the high level how we do async DR. And again, this is independent from any underlying infrastructure. So we have customers running production in an on-premise environment, doing the disaster recovery to a public cloud. We also have customers doing this in Amazon and disaster recovering this to another Amazon region or even to another public hyperscaler cloud. So you could do this between EKS and AKS or between Rancher on-prem and, don't know, GKE in the public cloud. This is Kubernetes, let's say, native. It's all YAML specs. You can put it into your GitOps pipelines and just apply it automatically. And this brings, first of all, the business continuity benefit, but also these ideas of having a single point of management for all the storage, taking out risks, standardizing, automating, all these pieces. So this is just a high-level overview of one of the features we can provide. If we go deeper into the let's say, daily business, okay, now we implemented the solution. Basically, Portworx is a storage system. Yeah? It's a software piece, it's a software-defined solution, but it basically implements storage. And now, what happens first if you implement a storage solution? You will run out of space. Because this is what happens when people start using storage systems. So in our platform, we have 2 pieces where you could run out of space. It's first, the physical volumes. If someone is creating a PVC, don't know, 10 gig, and he's filling this PVC, and now it's reaching 80% usage, 90% usage, what happens? You must change or increase the size of the volume. And this is a manual step. You should not do this because it's Kubernetes. You should not do manual steps, and it should not be needed. And we have a solution for this, and that's the Portworx Autopilot. Portworx Autopilot is just a default solution we just deploy within our clusters. And what we do is we basically consume our own Prometheus metrics. Yes, Portworx is exposing Prometheus metrics for everything we do. So we consume our own Prometheus metrics. And now you can build rules, and this is all YAML specs, defining which workloads to monitor. You're using labels, so you can say, I want each namespace having the label, don't know, databases, and all applications having the label monitor me. I want to monitor those, and if the usage of a PVC of one of those matching applications exceeds 80%, increase it by 20%. And you could also define a maximum layer. So you could say, okay, I'm providing 10 gig to each of my developers. Do this automatic increase of the volume size up to a level of 100 gig, not more. So you could also prevent that users are using too much storage. And this happens automatically in the background. So you create these policies. Again, that's YAML specs. You can put them into your GitOps pipeline. And now Autopilot will kick in, will consume all the metrics, will check if one of those rules hits. And if it hits, it will execute the function. And this is being done during operations of the clusters. So this is nothing which interrupts any production. Volumes will be just resized automatically. And this helps preventing application downtime, because if applications run out of space, they usually crash. And it helps also automating these day 2 operations. And as I said, what happens first on a storage system, you will run out of space. We also have a pool of storage we consume from your infrastructure, and out of this pool we create these PVCs. And also this pool could run out of space. And if you're running on a hyperscaler or on vSphere, we can automatically deploy also the backend storage we need. This doesn't work on a bare metal cluster because you will have disks in your nodes. But if you're running on vSphere, on Amazon, Google, or Azure, you can tell Portworx where to get the storage from, where it stores its data. And you can also create rules here what to do if this is also running out of capacity. So we can automatically increase volumes being consumed, but we can also increase our backend storage pool we consume from the infrastructure. And this again helps you automating these day 2 operations. So you should not get into one of those clusters and increase sizes of volumes, because if you have a large scale cluster, you can't follow up this. This was one of the features we implemented. Another thing we see is app I/O control, and it's about the noisy neighbor stuff. If you have many different users using your Kubernetes clusters, you might end up in a noisy neighbor problem. And this is about people are consuming I/Os, consuming bandwidth with maybe some performance-hungry applications. And on the same cluster, you have other applications which then would not have sufficient performance for their operations. And Portworx implements a function which is app I/O control, where you can set on a storage class layer how much bandwidth, how much I/Os, how much bandwidth a volume could consume. And it would limit this consumption. So users could not go above this. And this helps you preventing the noisy neighbor problem. And it also prevents of heavy I/O from some pods affecting other pods or consuming all the bandwidth being available. Again, important thing here, and you see it on this screenshot, we expose Prometheus metrics for everything we do because we are Kubernetes native. We also provide a huge set on Grafana dashboards where you can get all the details about the storage volumes we create, the IOPS, the CPU, the memory usage, latency, all the things you might want to see in case of something is not working as expected. And this helps you just to find issues. – 3. . 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. recover of data deleted accidentally or maliciously. So yep, you have a ransomware attack, and it now is a new ransomware which also attacks Kubernetes clusters. I don't know. We have a function called Portworx Trash Can. Yeah, first of all, you hopefully have a backup and recovery strategy for your clusters. So you have a backup solution in place to restore things which might be deleted. I see laughing. Okay. I won't talk about it. So you hopefully have a backup and restore solution in place. But sometimes you also want to have a solution just built in. And this is it's a small feature of us, but it's quite interesting. We have a volume trash can. So whenever someone is deleting a PVC, yeah, kubectl delete PVC, now it's gone. They could either do a backup restore if you have one, or they could use our trash can, which means you can define a threshold on Portworx which will keep a volume a certain amount of time after it's deleted. And this also helps you to quickly recover on ransomware attacks. I actually haven't seen ransomware attacks against Kubernetes, but you never know what happens in the future. But it might also be possible that someone tries a new script and deletes all PVCs unintentionally. So yeah, this could help you. You can control the lifespan of these volumes because, yeah, actually, if they are deleted and not actually away, then they still need storage. So you need to think about the lifespan you want to give it. But basically, this helps you in quickly recover data on these clusters. Going a step back, IDC has done some research on storage and storage providers for Kubernetes. And we are one of the leaders here in this marketscape. And I think the important thing is we are the only one leader. So we are mentioned here as Pure Storage because Portworx is part of Pure Storage. I think we are the only leader being independent from the platform and the infrastructure. Because if you take a look at the other two, well, SUSE is doing a good job here providing storage for Rancher, but it's actually working on Rancher. If you have OpenShift, if you have EKS, GKE, AKS, that might not be a solution for you. And same applies to the other ones, which are heavily hardware dependent. So, yeah, together with Rancher, you can just unlock what Kubernetes can provide you. So we can provide you a stable storage platform for your clusters. And we heavily focus on business continuity, developer productivity, so meaning how long does it take for a developer for you to get storage on your clusters? Is this something which happens quickly on a Kubernetes native way, or is this something which might take longer? And yeah, the outcomes for our customers are maximizing these productivity, optimizing the performance at scale, that's important, and deliver these enterprise-grade business continuity for all your workloads, not only Rancher, especially all of them. So we have a webcast on July 16th. So if you want to register, you can win a C64 Mini, if you know these boxes. So if you want to register, just take a photo or just ping me afterwards. And I would be open for questions now. Yep. So I need to repeat the question because it's recorded. So question is, it will completely replace Longhorn or Ceph? Yes. So it's a solution replacing the inbuilt solutions, whatever your Kubernetes distribution brings to you. Yep. Another question?
So one of the things you talked about was the performance of Portworx. Are there any benchmarks or comparisons between Portworx, Ceph, Longhorn that you guys would be able to point to?
So the question is about performance. The question is about if we have benchmarks against other solutions. Not public available, because as always benchmarks, well, if I do a benchmark, I will make my product look the best. So we are happy to support any of our potential customers in doing benchmarks and testing their workloads against Portworx and the other solutions, and I'm not feared going into this.
But it's also hard to benchmark because Ceph, for example, Longhorn doesn't have this feature.
Yeah, so yeah, question is, it's hard to benchmark because the others might not have the features. Yes, that's true.
You should be able to at least
If
benchmark like IOPS and what.
yeah. So if you just go down to a level of IOPS, bandwidth, and stuff like this, you might be able to compare. Yes, you see what happens and what you get out of it, but you also need to consider what's additional benefits you get into this solution. So we have published a benchmark because we often get the question, how much performance Portworx actually itself consumes. And on our website, on docs.portworx.com, if you search for performance, you will find a comparison where we just do a benchmark against, we're creating a volume and using a directory mount directly on a worker node. So we take a directory on a worker node and mount it into the workload, do a benchmark, and then we add Portworx to it. So we tell Portworx to consume the block device and then provide the storage from the same block device to the workload. So it's a one-by-one comparison. And there we see we roughly consume around 3% of the performance. So we consume around 3% because there's nothing for free. But if you then think about, okay, you have a directory mount, there is no redundancy. If you lose the worker node, the data's gone. With Portworx, you could now add replication. So you could create redundancy within your Kubernetes cluster. And regardless which worker node you are losing, you won't lose your data. And this is these additional benefits. So it's always important, if you do benchmarks, try to understand what you're actually benchmarking and what might other benefits you can't benchmark. Thanks for joining. Come to our webcast and have a great day.